Our ancestors had an extraordinary ability that continues to amaze us today. They could predict eclipses without telescopes or any modern technology. The answer to this remarkable feat is literally written in stone, through ancient megalithic structures scattered across the globe. These silent witnesses to human ingenuity have survived thousands of years to tell us their story. While Stonehenge might be the most famous prehistoric astronomical observatory, it represents just one piece of a much larger puzzle. From the Göcek Circle in Germany to the Caracol Observatory in Mexico, hundreds of ancient sites demonstrate our ancestors' profound understanding of celestial movements. Some of these structures, like the 7,000-year-old Nabta Playa in Egypt, predate Stonehenge by millennia and show even more precise astronomical alignments. Perhaps most intriguing is how civilizations separated by vast oceans and continents developed strikingly similar astronomical knowledge. From the Mayans in Central America to the ancient Chinese, and from the Celtic Druids to the Egyptian priests, cultures worldwide looked to the stars and reached comparable conclusions about celestial cycles. This convergence of knowledge suggests that the human drive to understand the cosmos is universal, transcending geographical and cultural boundaries. These ancient astronomers created sophisticated calendars and prediction systems by carefully observing and recording celestial events. They aligned massive stone structures with the rising and setting points of the sun during solstices and equinoxes. They tracked lunar cycles and planetary movements with remarkable accuracy, all without the aid of modern instruments. Their knowledge was passed down through generations, encoded in the very architecture of their monuments. Today, these ancient observatories continue to function just as their builders intended. During summer solstice at Stonehenge, the rising sun still perfectly aligns with the heel stone, just as it did over 4,000 years ago. At Chichen Itza, the shadows cast during equinoxes still create the same serpent-like illusion that amazed the Maya. These enduring astronomical alignments stand as testimony to our ancestors' remarkable achievements in naked-eye astronomy. Before we delve deeper into these celestial mysteries written in the stars and explore how our ancestors achieved such extraordinary feats, be sure to subscribe to our channel and turn on notifications. Join us on this fascinating journey through time as we uncover more revelations about our innovative ancestors who laid the groundwork for modern astronomy through careful observation and monumental architecture. The story of astronomy begins far deeper in time than many might imagine, in an era when our ancestors were still dwelling in caves and crafting tools from stone. Over 30,000 years ago, long before the first hieroglyphs were carved or the first cuneiform pressed into clay, early humans were already carefully documenting their observations of the night sky. One of the most remarkable pieces of evidence for this ancient astronomical knowledge comes in the form of carved bones, particularly the Blanchard bone discovered in France. This wolf bone, dated to around 32,000 BCE, contains a series of notches that perfectly correspond to the lunar cycle. These early astronomers used careful notch patterns to track the moon's phases, creating what we now recognize as humanity's first calendars. The sophistication of these early timekeeping systems is truly remarkable when we consider the context. Without any form of writing, without paper or parchment, without even the most basic mathematical notation, our ancestors developed intricate systems to track time and celestial movements. They did this by turning their environment into a vast astronomical instrument. Carefully positioned stones served as markers for the rising and setting sun at different times of the year. Shadow lengths were measured to track seasonal changes. Star positions were memorized and passed down through oral tradition. These early astronomers noticed that celestial events followed predictable patterns that coincided with earthly changes. They observed how the moon's cycles influenced tides, how the sun's path across the sky shifted with the seasons, and how certain star configurations heralded specific times of year. This knowledge wasn't merely academic, it was crucial for survival, helping communities anticipate seasonal changes, plan migrations, and organize agricultural activities. The development of these astronomical calendars represents one of humanity's first steps towards systematic scientific observation. Our ancestors didn't just passively observe the sky, they actively recorded patterns, made predictions, and tested their observations over generations. They created complex systems to track time without any of the tools we take for granted today, demonstrating remarkable ingenuity and determination. These early astronomical observations laid the groundwork for all future scientific endeavors. They marked humanity's first attempt to understand and predict natural phenomena through careful observation and record-keeping. The methods they developed, using natural markers and astronomical alignments, would continue to be refined and used for thousands of years, eventually evolving into the sophisticated astronomical calculations we use today. This early chapter in human history shows us that the fundamental drive to understand our universe, to track time, and to find patterns in natural phenomena is deeply embedded in the human experience. It reminds us that science and systematic observation didn't begin with written records or modern instruments, but with the patient observation and innovative recording methods of our distant ancestors. Picture yourself in a world thousands of years ago, where the night sky blazed with countless stars unobscured by artificial light. In this ancient setting, certain individuals emerged as the first astronomers of human civilization, the shamans, priests, and wisdom keepers of prehistoric communities. These early astronomers were far more than casual sky watchers. They were the scientists and record keepers of their time, spending countless nights studying the celestial dance above. Imagine a shaman, wrapped in animal furs against the cold night air, sitting atop a hill specifically chosen for its clear view of the horizon. Night after night, year after year, they would track the movement of stars, planets, and the moon, gradually building a mental library of celestial patterns. These prehistoric astronomers developed remarkable methods to record their observations. They might place stones in specific arrangements to mark the position of celestial bodies, create notches in bones or sticks to track lunar cycles, or paint complex symbols in caves representing important astronomical events. Their observations weren't just academic. They were crucial for their community's survival, helping predict seasonal changes that would affect hunting, gathering, and later, agriculture. The construction of megalithic observatories represents perhaps the most impressive testament to these ancient astronomers' knowledge and influence. These projects required enormous community effort and sophisticated planning. Imagine hundreds of people working together, quarrying massive stones, sometimes weighing several tons, and transporting them over considerable distances. The positioning of these stones wasn't random. It required precise astronomical knowledge accumulated over generations. These prehistoric astronomers had to understand complex celestial mechanics well enough to direct the placement of enormous stones that would align perfectly with astronomical events. They needed to factor in the horizon's profile, the changing positions of stars over centuries due to precession, and the exact angles needed to create shadows or light effects during specific celestial events. The construction of these monuments also tells us about the social organization of these societies. These weren't just individual efforts, they required community-wide cooperation and dedication. Hundreds or even thousands of people would work together, following the guidance of their astronomical experts. This suggests these early astronomers held positions of significant respect and authority within their communities. Consider the magnitude of their achievement. Without written language, without modern mathematical notation, without any of our current technological tools, they created structures that continue to mark celestial events accurately thousands of years later. Each carefully positioned stone became a page in humanity's first astronomical textbook, a book written not with words, but with massive blocks of stone aligned with the cosmos. These prehistoric astronomers were also teachers, passing their knowledge down through generations. They developed ways to encode complex astronomical information into oral traditions, stories, and songs that could be accurately transmitted across centuries. They created the first scientific traditions of humanity, establishing methods of careful observation, record-keeping, and prediction that would eventually evolve into modern scientific practices. Their legacy lives on not just in the megalithic structures they left behind, but in the very foundations of astronomical science. The patterns they first observed, the methods they developed for tracking celestial movements, and their understanding of celestial cycles formed the basis for all future astronomical knowledge. When we study the stars today, we are following in the footsteps of these first scientists who looked up at the same sky with wonder and dedication, seeking to understand the cosmic dance above them. The technological achievements of our prehistoric ancestors were far more sophisticated than many people realize. The stone circles and megalithic structures they built weren't merely impressive monuments. They were complex astronomical instruments that combined multiple functions in remarkably innovative ways. These ancient structures represented a quantum leap in prehistoric technology. Take, for example, the sophisticated engineering of Stonehenge. Its builders developed techniques to quarry, transport, and precisely position stones weighing up to 50 tons. They created interlocking joints in the stones that remained stable after thousands of years, using techniques that would challenge even modern stonemasons. The precise astronomical alignments required mathematical knowledge that wasn't supposed to exist in prehistoric times. Perhaps even more remarkable is Göbekli Tepe in Turkey, which has revolutionized our understanding of prehistoric capabilities. Built around 10,000 BCE, this site features intricate carvings that some researchers believe record an ancient cosmic catastrophe. The symbols and alignments at Göbekli Tepe may represent a comet impact that occurred approximately 13,000 years ago, potentially documenting one of the earliest astronomical observations of such an event in human history. The technological sophistication of these sites extends beyond their construction. Many stone circles functioned as complex calendrical devices. They could track not only solar events like solstices and equinoxes, but also lunar cycles and even eclipses. The megalithic yard, a standard unit of measurement used across numerous European sites, demonstrates a remarkable understanding of geometry and mathematical principles. These ancient observatories incorporated acoustic properties as well. Recent studies have shown that many stone circles were designed to amplify and focus sound in specific ways, creating impressive acoustic effects during ceremonies. This suggests an advanced understanding of sound wave behavior thousands of years before the development of formal acoustic science. The engineering precision achieved at sites like the Callanish stones in Scotland or Newgrange in Ireland is astounding. Newgrange's roof box, for instance, allows sunlight to penetrate the chamber only during the winter solstice, requiring incredibly precise architectural calculations. This level of accuracy was achieved without modern surveying equipment or mathematical notation. The technology of astronomical observation evolved differently across various cultures. In South America, the 13 Towers of Chanquillo formed a solar observatory that could track the annual movement of the sun with remarkable precision. In ancient Egypt, the pyramids were aligned with such accuracy that they deviate from true north by less than half a degree, a feat that would be challenging even with modern equipment. These prehistoric technologies weren't limited to large monuments. Portable astronomical devices have been discovered, such as the Nebra Sky Disk from Bronze Age Germany, which combines astronomical observations with sophisticated metallurgy. This 3,600-year-old bronze disk accurately depicts complex astronomical phenomena, including the Pleiades star cluster and the solar year. The technological achievements of these early astronomers laid the groundwork for future scientific developments. Their methods of tracking celestial movements and measuring time influenced the development of mathematics, geometry, and engineering. The precision tools they created for astronomical observation evolved into the scientific instruments we use today. These ancient technologies demonstrate that our ancestors possessed sophisticated scientific knowledge long before the advent of written language. They developed complex methods to observe, record, and predict celestial events, creating technologies that would influence human understanding of astronomy for millennia to come. What ancient astronomical discovery do you find most impressive? Is it the precise alignments of stone circles, the sophisticated calendar systems, or perhaps the ancient recordings of celestial events like the possible comet impact at Göbekli Tepe? Share your thoughts in the comments below, and let us know which prehistoric astronomical achievement captures your imagination the most. One of the most intriguing puzzles in prehistoric archaeology is understanding how ancient peoples achieved such remarkable astronomical precision without modern instruments. This challenge continues to fascinate archaeologists, astronomers, and engineers alike, pushing us to reconsider our assumptions about prehistoric human capabilities. The first major challenge these ancient astronomers faced was establishing precise measurements without standardized tools. They developed ingenious solutions, using natural phenomena as measuring devices. For instance, they could create remarkably accurate right angles by observing the shadow cast by a vertical pole at noon, and then using rope to mark equal distances from its base. This technique, known as the Indian circle, allowed for precise geometric layouts of astronomical structures. The challenge of tracking time presented another formidable obstacle. Without clocks or written records, our ancestors needed to develop reliable methods to measure both short and long time periods. They accomplished this through careful observation of natural cycles. The moon's phases provided a convenient monthly calendar, while the sun's annual journey across the horizon points marked longer periods. They developed sophisticated techniques to track these movements, using features in the landscape and carefully positioned markers. Perhaps the most daunting challenge was the need to predict seasonal changes accurately for survival. A miscalculation could mean the difference between life and death for an entire community. They needed to know when to plant crops, when to expect migrations of animals for hunting, and when to prepare for harsh weather. This vital need drove the development of increasingly precise astronomical observations and calculations. The construction of megalithic observatories presented its own set of extraordinary challenges. How did they move massive stones, sometimes weighing hundreds of tons, over considerable distances? Recent experimental archaeology has suggested they might have used sophisticated wooden sledges, rollers, and levers, combined with careful route planning and an intricate understanding of physics principles they learned through practical experience. The precision alignment of these structures required solving complex geometric and astronomical problems. They needed to account for the apparent movement of celestial bodies, the curvature of the Earth, and local landscape features. Without modern surveying equipment, they developed methods using simple tools like poles and ropes, combined with patient observation and precise positioning, to achieve alignments that remain accurate thousands of years later. Knowledge transmission posed another significant challenge. Without written language, how did they pass down complex astronomical information across generations? They developed sophisticated oral traditions, incorporating astronomical knowledge into stories, songs, and rituals. They also created physical mnemonic devices, using the very architecture of their monuments as a form of three-dimensional astronomical textbook. Weather presented yet another obstacle. In regions with frequent cloud cover, like Britain, making consistent astronomical observations would have been particularly challenging. They overcame this by developing methods to track celestial movements over extended periods, creating redundant systems of observation that could maintain accuracy despite gaps in direct observation. The challenge of calculating complex cycles without mathematical notation was particularly impressive. They developed ways to predict eclipse cycles, planetary movements, and stellar appearances using observational patterns and mechanical analogies. The accuracy of these predictions, achieved without written calculations or modern mathematical concepts, continues to amaze modern astronomers. Maintaining astronomical accuracy over generations required solving the problem of structural stability. They developed sophisticated engineering techniques to ensure their astronomical markers would remain precisely positioned for centuries. This included everything from careful foundation preparation to intricate stone-fitting techniques that remained stable without mortar. Perhaps most challenging was the need to coordinate large-scale community efforts over extended periods. Building and maintaining these astronomical monuments required significant resources and labor, demanding sophisticated social organization and leadership. They needed to convince their communities to invest enormous effort in projects that might take generations to complete. These challenges and their solutions reveal the remarkable ingenuity of our ancestors. They demonstrate that the human capacity for problem-solving and innovation has always been present, even if the tools and methods available were different. Understanding how they overcame these obstacles not only helps us appreciate their achievements, but also provides insights into human capability and determination that remain relevant today. The astronomical knowledge developed by our ancestors continues to influence and inspire us today. Just as they used the stars to navigate and orient themselves in time and space, modern civilization still relies on celestial observations for crucial aspects of our daily lives. Consider navigation, for instance. While we now have GPS technology, the fundamental principles of celestial navigation developed by our ancestors remain vital, particularly as a backup system for modern navigation. Ships still carry sextants and celestial navigation equipment, and pilots are trained in celestial navigation techniques. These ancient methods proved their enduring value during recent conflicts when GPS systems were compromised, demonstrating how ancient wisdom can serve as a crucial fallback for modern technology. The prehistoric understanding of astronomical cycles continues to inform our modern calendar systems. The ancient division of time, based on lunar phases and solar years, remains the foundation of how we track time today. Many of our time measurement units, from the 7-day week to the 12-month year, originate from ancient astronomical observations and have proved so practical that they persist in our digital age. Ancient architectural principles based on astronomical alignments have found new applications in modern sustainable architecture. Architects studying prehistoric structures have rediscovered how strategic positioning relative to the sun's path can naturally regulate building temperature and lighting. These ancient design principles are now being incorporated into green building practices, showing how prehistoric wisdom can contribute to solving contemporary challenges. One fascinating discovery about our ancestors' astronomical knowledge comes from studying ancient rock art. Those seemingly decorative spiral patterns found in cave paintings and petroglyphs across the globe often held deeper astronomical significance. Many of these spirals have been found to represent specific celestial events, from solar observations to lunar cycles, and even the tracking of Venus and other planets. Some spiral patterns have been identified as recordings of ancient supernovae, while others map the changing positions of celestial poles over long periods. The prehistoric practice of archaeoastronomy has evolved into modern scientific disciplines. The careful observational techniques developed by our ancestors laid the groundwork for modern scientific methodology. Their practice of long-term sky watching and precise record-keeping established patterns of systematic observation that remain fundamental to scientific research today. The ancient understanding of celestial cycles has also proved valuable in modern climate studies. By studying how our ancestors recorded astronomical events and associated weather patterns, scientists can reconstruct historical climate data, helping us better understand long-term climate changes and their impacts on human civilization. Our ancestors' achievements in naked-eye astronomy remind us that sophisticated technology isn't always necessary for significant scientific discovery. Their ability to make precise observations and predictions using simple tools demonstrates the power of patient observation and systematic record-keeping. This lesson remains relevant in modern citizen science initiatives, where amateur astronomers continue to make important contributions to our understanding of the cosmos. The prehistoric recognition of celestial cycles' influence on terrestrial life foreshadowed our modern understanding of chronobiology. Their observations of how astronomical cycles affect natural phenomena laid the foundation for our current research into biological rhythms and their relationship to celestial cycles. Perhaps most importantly, our ancestors' astronomical achievements demonstrate humanity's enduring curiosity about the cosmos. The same questions that drove them to build enormous astronomical monuments continue to inspire modern space exploration and astronomical research. Their legacy reminds us that looking up at the night sky and seeking to understand our place in the universe is a fundamental part of the human experience. As we continue to advance our astronomical knowledge with sophisticated technology, the wisdom of our ancestors offers valuable lessons about patience, observation, and our connection to the cosmic cycles that govern our world. Their achievements remind us that each scientific advancement builds upon a foundation laid by countless generations of curious minds looking up at the same stars we see today. The precision of ancient astronomical structures continues to astonish modern scientists. The Maya pyramids, for instance, represent one of humanity's most accurate solar calendars, demonstrating a level of astronomical knowledge that rivals modern calculations in its precision. The El Castillo Pyramid at Chichen Itza serves as a perfect example of this sophistication. During the spring and autumn equinoxes, the afternoon sun creates a pattern of triangular shadows along the pyramid's northern stairway, giving the appearance of a serpent descending the steps, an effect that still occurs with perfect timing today. The Maya pyramids weren't just individual structures, they formed an interconnected astronomical calculator. The positions and alignments of various pyramids tracked not only solar movements, but also Venus cycles with remarkable accuracy. Their calculations of Venus's orbital period were off by only 2 hours every 500 years, a level of precision that wasn't matched by European astronomers until the 18th century. Even more remarkable is how the Maya encoded complex astronomical information into their architecture. The 9 levels of the Pyramid of Kukulkan, split by a staircase, create 18 separate terraces that mark the 18 months of the Maya calendar. The 4 stairways have 91 steps each. Combined with the temple platform as the final step, they total 365, representing the days in a solar year. This architectural calendar maintains its accuracy over 1,500 years after its construction. Stonehenge's astronomical precision is equally impressive. Recent studies have revealed that its builders understood complex astronomical cycles well enough to predict eclipses with astonishing accuracy. The monument's sarsen circle and trilithons were positioned with such precision that they can track both solar and lunar movements. The station stones at Stonehenge form a rectangle that precisely marks the most extreme positions of the moon's rising and setting points over its 18.6-year cycle. The accuracy of Stonehenge's eclipse prediction capabilities stems from its builders' understanding of the metonic cycle, a 19-year period after which the moon's phases repeat on the same days of the year. By incorporating this knowledge into the monument's design, they created a sophisticated calculator that could predict both solar and lunar eclipses. Modern calculations have shown that these predictions would have been accurate to within a few hours, an extraordinary achievement for a civilization without written language or modern mathematical notation. The astronomical abilities of these ancient structures extend beyond their most famous features. For instance, the Maya site of Uaxacton contains buildings aligned to mark the solstices and equinoxes with such precision that they could be used to calibrate modern astronomical equipment. At Stonehenge, the Aubrey holes, a ring of 56 pits around the monument, may have been used to predict lunar eclipses through a sophisticated counting system. These ancient observatories also demonstrate remarkable engineering precision. The Maya pyramids are aligned to true north with an error of less than 1 degree. Stonehenge's central axis is perfectly aligned with the summer solstice sunrise, despite being constructed over several centuries without modern surveying equipment. The engineering required to achieve such accuracy would challenge even modern builders. The durability of these astronomical calculators is particularly noteworthy. Despite centuries of exposure to weather and geological movements, both the Maya pyramids and Stonehenge maintain their astronomical alignments. This persistence allows modern archaeoastronomers to verify their original calculations and confirm their remarkable accuracy. Perhaps most impressively, these structures achieve their precision through entirely different methods than we use today. While modern astronomers rely on complex mathematics and sophisticated technology, ancient builders created equally accurate calculations through careful observation and architectural innovation. This achievement forces us to reconsider our assumptions about ancient technological capabilities and mathematical understanding. These extraordinary examples of ancient astronomical precision remind us that our ancestors' scientific achievements were far more sophisticated than often assumed. Their ability to create enduring astronomical calculators, encoded in stone and maintaining their accuracy over millennia, stands as a testament to human ingenuity and our enduring drive to understand the cosmos. From the humble beginnings of notches carved in bones to the majestic pyramids reaching toward the sky, our ancestors' journey of astronomical discovery represents humanity's first steps into scientific thinking. This remarkable progression from simple observations to complex predictions demonstrates how the fundamental principles of science emerged from our species' eternal fascination with the celestial realm. Our prehistoric ancestors' methodology, careful observation, pattern recognition, and systematic recording established the foundation for all scientific inquiry. They developed these principles not in formal laboratories, but under the vast canopy of stars, proving that the seeds of scientific thinking were planted long before the advent of modern civilization. The evolution of astronomical knowledge, from basic lunar calendars to sophisticated eclipse prediction systems, mirrors humanity's intellectual development. Each generation built upon the knowledge of their predecessors, gradually transforming simple observations into complex astronomical understanding. This process of accumulating and refining knowledge remains the cornerstone of modern scientific progress. These early astronomers were also humanity's first teachers, developing methods to preserve and transmit their knowledge across generations. Their legacy lives on not just in the monuments they left behind, but in the very way we approach scientific discovery. When modern scientists make careful observations, record data systematically, and look for patterns in natural phenomena, they are following in the footsteps of those first skywatchers. The next time you gaze up at the night sky, remember that you're participating in a tradition that stretches back to the very dawn of human consciousness. Those same stars that guide our satellites today guided our ancestors as they took humanity's first steps toward understanding the universe. The questions that filled them with wonder about our place in the cosmos, the cycles of celestial bodies, and the nature of the universe continue to drive scientific inquiry today. Like our ancestors, we still seek to understand our place in the cosmic dance. While our tools have evolved from stone circles to radio telescopes, our fundamental quest remains the same. Each new astronomical discovery, whether made by ancient skywatchers or modern astronomers, adds another chapter to humanity's ongoing conversation with the cosmos. The prehistoric roots of astronomy remind us that science isn't just about advanced technology. It's about the human desire to understand our world through careful observation and reasoned thinking. Our ancestors' achievements demonstrate that remarkable discoveries are possible with simple tools when coupled with patience, dedication, and systematic observation. As we push the boundaries of astronomical knowledge with our modern instruments, we build upon a foundation laid by countless generations of skywatchers who came before us. Their legacy continues in every astronomical observation, every scientific discovery, and every moment of wonder when we look up at the night sky. If you've been amazed by the astronomical wisdom of our ancestors, you're not alone. This connection between past and present, between ancient skywatchers and modern astronomers, reminds us that we're all part of humanity's ongoing quest to understand the cosmos. Their story is our story, a testament to human ingenuity, curiosity, and our eternal desire to understand our place among the stars. Don't keep this fascinating journey of discovery to yourself. Share this video with friends who share your passion for astronomy and history. Give it a thumbs up if you've gained a new appreciation for our ancestors' astronomical achievements. Subscribe to our channel for more captivating explorations of humanity's scientific heritage, and don't forget to hit that notification bell to stay updated on our latest videos uncovering the remarkable stories of human innovation and discovery. Join us next time as we continue to explore the fascinating intersection of ancient wisdom and modern science, revealing how our ancestors' insights continue to influence our understanding of the cosmos today. Until then, keep looking up. You're carrying forward a tradition as old as humanity itself.